Yeah, ちょっとじゃあ、start today's class. Yes. Today's class is about last week, we are medical. So, last week のコンテンツは何でしたかって言ったら、last week コンテンツ5。5のコンテンツは何ですか？間違えた。5のコンテンツは何でしたかって言ったら、last week はメディカルか。メディカルロボット。So therefore, last week we are exploring mainly about the surgical robot, medical robot, but especially about the surgical robot we are looked last week. Okay. So, and then today, welfare. Welfare robot means the welfare robot. これ、daily life, public service robot, medical welfare, rehabilitation, 3 categories I have settled. And then what is the meaning of welfare means the subject って言うんだ。subject. Target person. Target people is elderly people, disabilities, physically handicapped, physically challenged person. And the objective is nursing care and lifestyle support, daily life supporting. So the task is, the one is a communication help, communication support. The other is daily activity support. Daily activity support means mainly the physical support. Yes, the communication means informative support, and the daily activity support is physically support mainly. And, えーっと、えーっと、えーっと、今日の ちょっと、today's content is これどれ見るといいんだ？これ見るといいのか？モーションアシスト、アッパーリム、ローワーリム、パワーアシストと、なんか、next week we are looking for the rehabilitation. So therefore the welfare today is mainly about the motion assist. At the beginning part only communication support, but mainly about the physical power support, upper limb and lower limb for daily movement. で、today's question, given questions. One is the hand finger processes. List and explain the 5 finger movement patterns necessary for daily lives. So, because the artificial finger, if we want to develop artificial finger, firstly, we should consider which kind of task is necessary to prepare. なんか maybe many of the artificial hand has the preliminary decided movement pattern has been equipped in the system. So therefore, which kind of movement pattern is appropriate or not, I hope you should consider. So therefore, considering relationship between finger movement and the performed task. It is said. Next, secondly, is not only the movement, but also control. This and explain the operation and control method of the movement pattern of the hand finger processes, which categorize into maybe the mechanical method, mechanical operation, and the electrical commanding, maybe, and others. Thirdly is the lower limb processes, list up and explain the two-leg movement pattern necessary for daily life. What's the relation between the leg movement and the performed task? This is similar to the first one. And fourth, control of the roller limb processes. This is also the, the corresponding to the question two. Explain the two main approaches to process the surface EMG, electromyography signal for the control of the lower limb processes, that is supervisory EMG control paradigm and the direct EMG control paradigm. で、まあ、mainly categorized into two types. But what it is you have to consider. っていうのが question 4で、question 5, control of electric chair. So maybe many electric chairs has already been the research and developed, and also some of them is commercially available now. So therefore, you should pick up something, and which kind of command input is their input method is their, まあ、これはインターフェースプログラム and control program か。まあ、not only limited in these questions, but to which part you are interested in today's contents, I want to hear from you firstly. So therefore, please answer to which part of this today's contents you are interested in. はい。first discussion is your interest. Your interest. はい。which part you are interested in today's subject or today's content of today's topic?
I'm interested in learning.
はい、please say again.
I'm interested in the lower limb processes.
はい。Why you are interested about this?
Because it can help disabled people to active their limb.
Disables. To help.
To active their limb.
なんか、more details, なんか、メカニカルパートとか、コントロールパートとか、アクチュエーターパートとか、センシングパートとか、which part you are interested in the lower limb system?
The direct EMG control.
EMG control. EMG control ってそんな使われてる？はい。サンキュー、サンキュー。いいか。じゃあ、next, チェナの what is your opinion?
I actually prefer the EMG control about.
はい。
I actually prefer the EMG control system for my actually main interest, especially for the directly EMG because it shows actually not only for the limbs but also for other sensors that makes that this kind of research makes us find that our brain could just fit new type of our bodies just by trying to study from them.
Direct EMG is very related to the brain signal.
Right, because it's not only just the brain signal. Because it's just a need fairly simple input from the EMG from the nerve, and the ourselves could study from the feedback of the presented And by these feedbacks, we even could try to study for how to use a definitely new part of our body. It is very, very interesting, right?
Thank you, EMG. Right, thank you. Just about Aoki-san.
Hi. I'm interested in the wheelchair which controlled by the brain signals. Because I think that it can help the disabled people move by themselves without their hand control some tables or something else. It can really improve their life. I think it is very meaningful.
You have studied about the wheelchair operation by brain signal.
I don't know this technology before. I just read some article by myself.
How about thank you. Finally, Ifan, please.
Because I actually bought an electric wheelchair for my grandmother, so I have some real experience about it.
なんかエレクトリックチェア she is using now?
No, he just used once and she's frightened about it. So he used the manual wheelchair.
Okay. Present. Not
，Let me share my. If here could be seen, if my work could be seen, because of the computer doesn't have some, the computer doesn't have the power, so I have to use the cell phone to share. Here's the question 4. Firstly, the supervised EMG control. The supervised EMG control is just like we just need a kind of signal that makes the start or stop, and the control, the prosthetics as a kind of robotics system could selfly work about it. It could work by itself. So this is called the supervised. It doesn't means it means that you should needn't to control the actual exact movement of the itself. Your nerve signal is just for that to give a signal that's start or stop. It has the basically example is the autogenian bionic prosthetic knee. That the advantage of it is reduce user cognition and the muscular workload, enable stable and safe gait in structural environment, and well suited for user who is limited reducial muscle control. Right, it's just a fairly useful for some bodies that don't have able to export the nerve information. And however, I'm actually more interested in the directly EMG control. It means that to acquire and get the information on the surface of the muscles and get a lot of information from the end of the body and drain the nerve signals, the muscle signals from just like using EEG to collect our brain's activities, but it's actually collected the outer place of our nerves, and it could control the mechanics just like control our muscles. So the most advantages is provide the high flexibility and real-time adjustabilities because of our control system directly outputs into the machine itself, and it actually has support more neutral nature interactions and variable terrain adaptations. For the nature uh, for the nature interactions, it's just like that. We are trying to study a new body part of us. um, there's some researchers that shows that using directly EEG, it seems like we have to study just like a baby, and when we get to grow up, uh, we our brain regard it as a part of our real body. So this is fairly interesting as our brain has strong adaptation, and we could fastly acquire the new parts of our bodies, just regard it as a part of us. However, it also have limitations. It requires user training and consistent muscle control, and it's actually nowadays more computational demanding, and requires advanced filtering. It means actually we have to do better to better pre-process for the information that we collected from the muscles, and to make sure what is the actually action that the user would try to submit. Thanks a lot. This is my reply of this EEG system.
The most important point, what do you think?
My thinking is actually strong. That I'm strongly interested in directly EEG, and the directly EEG is basically the future, because it means that we directly interaction with the system itself, and we just even for the complete even for the people who doesn't have the disabilities, they could also use the directly EEGs for better performance, and it could be a new part of our bodies. Just think about that. So we got more limbs, more hands. That it could be very interesting word as this technique develops. Because the supervised EEG is just like the people who just press a button, but for the directly EMGs, it's just like we have another link. We could precisely operate them using our brains, just like trying to study a new link that's newly grow from our body.
Yeah. Can you prepare your report? Which kind of reference you have? Please share your reference.
Because my computer doesn't have power, I would like to share my reference, but now I can't. It's true. My computer doesn't have power. Today I'm using my cell phone. I forgot to bring that. This is the main problem.
Preparation for attending is very, very important.
I'm very sorry that this part of work, my reference actually said a lot about it. Especially it contains a kind of article and also some videos that the EMG control, especially the direct play. Just this active knee. My using reference in my using reference, it doesn't become fairly strong, but in much more stronger for much more stronger things that there's a kind of research called another thumb has videos could be easily to be searched on the YouTube.
You show it.
But I can't.
For lower limb process, that is the supervisor EMG control paradigm and the direct EMG control paradigm. Firstly is the supervisory EMG control paradigm. It have a picture. It shows directly shows the supervisory EMG control. It firstly gets the muscle signal from the human, and this muscle signal will processed by a feature extraction, and then they become the electricity signal. Then the electricity signal will control the motor of the mechanic and that is the direct EMG control paradigm. We can see this picture. The direct EMG control paradigm don't have the feature extraction model. In the muscle signal will directly will directly be the input of the of the すみません。It will be the direct input of the machine and the signal will only pass a real-time EMG decoding model, and then they can be the electricity signal and will be used. はい以上です。
ちょっと、by using your figures, the copied from some paper, please explain the difference between the supervisory control and the direct control.
About the difference. About the difference, I think it is meaning about the feature extraction model. The supervisor EMG control must need the feature extraction because they need the model to distinguish the muscle signal means what means. And then they give a signal. For example, this muscle signal means this man wants to work forward, and it must firstly pass by the visual extraction, and then we get a electricity signal. This signal is used for the motor, which means the motor move around. And but for the direct EMG control, you don't have the feature extraction. This signal may means that it might want to move forward, and then just need to pass a real-time EMG decoding. This signal have not be changed. Just have not be changed by the feature extraction, but directly used by the machine, and the machine will do the mutation of move forward. I think it is that.
So, first, the supervisory EMG control. So in this paradigm, so surface EMG signals are used to identify the user's intended locomotion mode, such as walking, stair ascent through EMG pattern recognition. Once a mode is recognized, the process switches to a pre-programmed low-level autonomous control mode that governs joint behavior. EMG signals are only used during transitions between locomotion modes. So the features of this control mode is EMG pattern recognition used to classify locomotion modes. Control transition triggers based on classification results, and low-level joint control is autonomous and mode dependent, suitable for rhythmic, repetitive tasks, and performance depends on EMG signals quality and passive robustness. The direct EMG control in this approach, EMG signals from antagonist muscle pairs are used to continuously and directly control the processes joint machines, such as torque or stiffness. This method attempts to mimic the biological neural muscle control and does not require predefined locomotion modes, and the user continuously modulates processes in real time through voluntary muscle contractions. The feature of this control mode is continuous EMG signals directly drive joint dynamics, mimic natural neural muscle control. No locomotion mode classification is needed enable more diverse and flexible movements and requires user training and precise muscle control. So yeah, I don't know.
The outlet is that the muscle being activated, and the muscle is the strong signal, and the muscle receives the nerve signal, and
to explain about this, what is the one one thing you have to say at the beginning? You know what you should say at the beginning of your explanation. Agonist antagonist.
It should say that what is the what is the signal of the muscles?
Yeah. For example, when we explore the agonist antagonist, this kind of answer by this search engine shows agonist and antagonist muscles are pairing muscle groups that work together to produce movement. Agonist is a muscle that contracts to create the movement, while the agonist is a muscle that relaxes or tenses to allow the movement to occur. This is true. But to explain this, to say this, what do you have to know? Or what do you have to say?
The first we should answer what is it on what this definition is on what, and what is the definition comes from. It's how it is it is true description for what things had the this is the true description for two situations in which part. This we should do the describe first.
How do you think? Do you know what we should say at the beginning to explain about this kind of agonist muscle, antagonist muscle? So,
Agonist muscles, um, I think we should start from the human body structure because it is the muscle of the human, and what's the word? Maybe maybe I think this kind of word maybe from the anatomical anatomical. I think this word maybe from the anatomical. So maybe we can firstly start from some knowledge of the anatomical. I think it may be a good idea. Anatomical. そう。
ってことね。アナトミカル、something. We should know what this link is. This link is. で、何ですかってここに、そう。筋肉、muscle is here and here. アゴニストマッスル、アンタゴニストマッスル。このペアっていうのが、あっていうのに、ペア、ペア、2マッスルペアっていうのが重要なので、This is important. Both sides.
A pair, it means that, for example, when I move my arm like this, the muscle above the arm will be shortened, and the muscle under the arm will be more length, will be more long. Shorten and lengthen.
Muscle is always become shorter. Contract.
Contract. I saw contract.
Only this direction. This can only produce a force. Only contraction force. So therefore, the only for example, the upper part of the muscle upper, muscle lower. If only the muscle upper contract, this knee elbow joint can be bent. But to make it go back to the original position or the extension, this lower muscle must be contracted, and this upper muscle should be relaxed. Only the contract or relax the muscle can do. Contract or relax the muscle can do. So therefore, contraction is a pulling power or shortening power, and the relax is only the normal, no force condition. So this is a muscle's most important feature. Only contract. Can only contract. Maybe they only produce a contraction force. So therefore, the one joint move both direction, both sides. This kind of pair is necessary to muscle system. So therefore, the agonist-antagonist system, for the one is pulling muscle is say the agonist. The antagonist is relaxed one. So sometimes the upper arm become agonist and the lower muscle becomes the antagonist. But to extend the upper muscle becomes the antagonist and the lower muscle becomes the agonist. The role will become changed to make the both direction movement of elbow joint. So the muscle's important feature is contract we have to say this, and then the anatomical structure is there. These are one important point you have to. So I have asked to the Ethan about this. You say that Afghanistan. Hi, thank you. Yeah, next.
Explain two main approaches to process the surface EMG signals for the control of lower limb prosthesis. Supervisory EMG control paradigm. In supervisory EMG control, EMG signals and gait events are used to classify the user's local motion mode. The classifier's decision determines transition between the predefined fitness states and thus the specific low-level control of prosthesis operation associated with the identified locomotion mode. The direct EMG control paradigm. In direct EMG control, the magnitude of EMG signals recorded from residual muscles directly and continuously modulates the prosthesis joint dynamics. Various control laws can be used to continuously map EMG activity to ankle control torque to drive prosthesis dynamics.
Thank you. Yes. Same manuscript. Journal article we have referred. Okay, so this is one. You should read this paper. Okay. So, this paper is gives so this paper. This paper gives information about the direct from deep question. Control lowering processes at the view of the electromyography interface control paradigm and the challenge and future direction. 2021. これどこにで、今、ここで、スーパーバイザリーっていうのは、なんか、クラシフィケーションして、given to this motor control. But to the directory of the directory, the intention of flexure or the contraction is measured and then inputted to the muscle. This is the now signal is directly controls the muscle contraction. This is set in this data. Fine, thank you for your question 4. And ゆえ、do you have more question about the EMG signal control? Your part is your interest. He wants to know your question or your concerns about or interest about the EMG control. You do you explain more? What is your intention? Or what do you want to talk more or not?
No, I think that's enough.
That's enough?
Yeah.
OK, OK. じゃあ、related to this, ちょっと、じゃあ、we should watch some related video. 例えばね、for example, もう、ちょっと今日いい加減になってますけど、これ、なんか、ストレステスティング、リアルライフプロトレク、ワイヤー。Do you watch it? Did you watch it? なんか、this is interesting. Interesting. So, therefore, まあ、ちょっと、if we watch it, it is more than 10. But ちょっと、まあ、starting, we should watch it.
When you have a long history of bad knees like me, jumping off a ledge with a 50-pound weight on your back is a surefire recipe for months of PT and crutches. But when you're wearing a military-grade robotic knee brace, theoretically, you should be okay. Moment of truth. I'm like very nervous. I know. I'm Brent Rose, and I'm about to pay for my orthopedist's Hawaiian vacation. 3, 2, 1. Oh, yeah, baby. All day. Sweet. You're not going anywhere, Dr. Shapiro. Let's jump off a roof. So you've heard about augmented reality, right? Well, how about augmented mobility? Robotic exoskeletons have captivated us for years. They're major tropes in sci-fi movies like Aliens, Elysium, and Avatar, but in real life, engineers have been working on them since the early 1900s, generally with terrible, clunky results.
Here we see the electrically powered machine built into the form of a human skeleton.
While there have been some real breakthroughs in recent years, most of them are still bulky, prohibitively power-hungry, as well as expensive. That's why a San Francisco company called Robotics caught my eye. Rome claims to have solved a lot of these problems, making a robotic knee brace that promises to double your strength and endurance and reduce experienced G-forces by half, all while doing it in a package that's lightweight, lasts up to 8 hours, and is relatively affordable. If you think that sounds too good to be true, you're not alone. So today, we're going to stress test the hell out of this thing. Oh yeah, how does that feel? Definitely feeling it though. And considering I just re-injured my knee, we're going to be stress testing me too. Ooh. Slip.
これは、this equipment is exoskeleton type and the knee, only leg knee supporting. So, ちょっとまあ、this is.
I'm fine.
I'm Tim Swift. I'm the founder and CEO of Robotics. So we have one line of product, which is a performance product, which is Forge. And that is really designed for military first responders.
What are some of the specific applications that you've seen it used for first responders and military?
Firefighters. Firefighters walk in with significant amounts of gear, and it's unacceptable for them to find themselves impeded. If there's fires that aren't on ground floors or multi-story buildings, they're not taking elevators up to those needs. They're carrying their gear and typically backup gear. Some of our customers are sending an extra guy for the sole goal of carrying all the gear, because they know by the time they make it to the 28th floor, that guy's smoked. His only job is to carry the gear and get out. We go out with maritime users in small boats, and these guys are taking, 50-mile-an-hour speeds over 10-foot sea states, and they're just getting beat by the G-forces. And we can put systems on users, and we get a 50% reduction in G-forces immediately. No training involved.
I'm excited to beat myself up in this thing.
It's great.
What makes Rome's military leg brace unique is that it uses pneumatic actuators instead of heavy motors and servos. That means it's using compressed air to augment your knee movement, and in theory, give you up to 2 times your own strength.
これ、ニューマティックね。エアーモーターという。エアーモーター is supporting.
Specifically, this is designed for military members or first responders, so the size is probably pretty close to where you're at.
Yeah,
No, firstly is a firefighters, he said, but presently is mainly for the military applications.
Journalist, military, first responder,
Perfect, right?
It's about the same.
You have a brace on each leg, and then you have a power pack that powers both of them. So that comprises kind of the 2 main parts of the system. This contains the compressor, some of the brains, and that work in conjunction with the sensors on the units themselves, all controlled by the remote that's on your left shoulder. If you want to go ahead and press and hold, that'll turn it on.
All right, moment of truth.
ここにオペレーション
Good morning.
スイッチ。
Oh, yeah. Yeah, it's very springy. I couldn't help but notice that anytime I move, there's a bit of a noise coming out of it. What is that we're hearing?
Yeah, so what you're hearing right now is the compressor itself charging up air to supply to each of the braces themselves. Part of what you're also hearing is when you move, there's the filling portion for the actuator, and then as you come back up, you'll hear venting. So some of that is both the brace sound and the power pack sound. Something we're working towards reducing, but that's what you're hearing, and that's what some of the vibrations are that you're feeling.
Okay, so we're going to start with a control test, and to do that we're going to do some squatting, which I haven't done in like 20 years. Normally you want to do this to failure. Failure for me, since I have a freshly tweaked knee, is going to be any inkling of pain, or just me passing out with a dumbbell on my head. All right, so this is 185. Let's see how this goes. How red is my face right now? Whoa! Yep, we'll call it good. 4 is good. Now I've got the forge on. We're going to turn it up to max support mode and see what we can do here. All right. It's okay to be scared. Here we go. Huh. Definitely feeling a lot more push on my backs and my thighs. I also don't feel like I'm about to have an embolism.
To realize this kind of supporting, what kind of control is necessary, do you think?
Also, it should be the feedback system that should get the firstly, it should receive the movement that the accelerators that makes the movement, what the movement should be made, and actually also the movement that be ended. It should it is amplifier for the actual movement itself. It just detected the movement from a person and amplify the movement itself.
Okay, yes. So sensing is a most important point.
Right.
Yes. So sometimes the gravity sensor, gyro sensor, acceleration sensor is used.
Sure.
But sometimes the EMG signal is used to take some intention of using.
Sure.
Yes. So, let's continue to watch this movie.
So that's good. I can still have a conversation. So that's good too. Oh yeah. I am definitely feeling it though. Let's call that failure. 8. I'm pretty happy with that. I'm gonna go pass out for a second here. It's fine. Everything's fine. So the forge isn't built to assist with your running, but it is built in such a way that it shouldn't impede your running. So when it's powered off, it's not getting in my way, but it's not assisting either. It's not designed to assist, but let's see what happens. That's never gonna get old. It's really huffing and puffing. Let's go up to 6. All right. So I can feel there's some resistance, and I can't tell if it's making it harder or easier. Again, I'm still feeling the weight, I'm feeling the pressure in the back of my thighs and around my ankles, but my knees feel totally fine right now. So that's good. It's not helping, but if I turn it off again, oh yeah, let's go without. Definitely better without. Yeah, so I tried at level 1 and at level 3. It was definitely impeding a little bit. It's just kind of resisting against your knees in a way that doesn't help you. It took some of the impact off my knees, which was nice, but I was kind of having to fight against it. So if you got to run with this thing, turn it off.
So please say something.
This kind of running part means it has still cannot be the feedback be so fast as it need time to be compress the air and the drive. So even if we use this system for the help of running, it could not get the frequency of our legs that's really in the running activities. It could be slower than when we it's the movement of this system is slower than our legs movement, so it has no any help. It has no help to our runnings.
Yes, 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 yes. そう。なんか、So you have learned the supervised EMG control and the direct EMG control.
Sure.
The only turn on the control signal is no good. So therefore, yes, running is a cycling movement,
Sure.
and the cycling, the force support is necessary. Sometimes it's good, but sometimes it's no good because the running speed will become different.
This work is actually designed for a stronger torque. It is actually a traditional mechanical problem. The system designed for torque and the system designed for the designed for the speed is definitely different design.
Okay, yes. Yes, so the resistance is sometimes some delay or the fan putting up the actuator is working, so therefore it makes more resistance in some case. Yes.
This is the impact test, which I'm rather nervous about. We don't have a boat, but this is going to simulate a sort of high seas situation and the impacts that I'd be taking on my legs. We're on the high box. This one's a little bit scary for me. 3, 2, 1. Feel it on my feet. Excuse me. Burrito. Actually want to try to do that one again with the Spider-Man landing. Oh, hell yeah. It's worth noting that while we're just testing the Forge today, which is designed for these types of high impacts, Rome has two other models, the Ascend and the Elevate. The Ascend is designed mostly for people with knee issues, and it helps them with things like standing and sitting and going up and down stairs. The Elevate is made for skiers whose knees aren't what they used to be. I actually got to test it in Big Sky, Montana a couple winters ago, and it did in fact help me power through turns with less strain on my knees. Though the sounds of the air compressor in an otherwise tranquil place was pretty hard to ignore. So the Forge did pretty well in the lab in some controlled testing. So let's try a little less controlled testing. They told me specifically that it will not help me dunk a basketball. We're gonna prove them wrong. Perfect. All right, I'm all forged up now. Let's see if this improves my vertical at all. No. Come on, baby. I cannot fly. I was wrong to believe that I could fly, and I feel stupid now. Okay, fine. So it was not designed for dunking. Let's try a few things that it was designed for. So,
いやいや、はいはい。ね、ですかね。So, therefore, it means and designed for which purpose is one important point. Because the control way will be very, very different in the daily life activities, depending on its activities, kind of activities. And also the constant or cyclic supporting is more acceptable or more easy to produce, to generate. But the more complex and sudden something is not good because for example, this system is using the air, the pneumatic is response is not so good. So therefore this kind of supporting actuator needs high speed response. But the pneumatic actuator, yes, maybe why they use the pneumatic actuator because it's back move. バックロード、バックドライバブル、in some case, in dangerous case. So therefore, the pneumatic is a safer choice for actuators rather than the electromagnetic actuators, for example.
It has because it is actually for the heavy load.
Yes.
It doesn't make it needs torque but not speed. Even just to use the same kind of air actuator, it doesn't mean that it cannot do the speed, but it needs to redesign the system itself. It could not. It could not hold so much load and it could be faster. This is a kind of a balance between the torque and the speed. It is just like in our in our vehicles, the cars and the trucks. The cars could accelerate faster and actually they also could get the faster maximum speed, higher maximum speed. However, the truck could gives more torque to get more load. They usually have the similar they have the similar power itself. They have the similar power. However, the speed and the torque, the speed multiples the torque is the power.
Okay, okay. はいはい。まあ、pneumatic actuator selection is also one reason, maybe. And also the control method, or feedback control, feedback gain tuning is very important for depending on the target application to the target situation. Yes, this video is the wired の some series of the なんか product test っていうか、なんだ、モックアップモデルテストみたいなもんで、This is a 2021の、Yes, this is one interesting video. まあいいや、ちょっと、じゃあ、to move to the another, yes, this is this is similar to this muscle suits とか、this is also the pneumatic actuator usage, andこれアッパーっていうか、waist とか、back pain prevention system. So therefore, this kind of thing is also developed in Japan. Hi. And this is one video. I'm sure. Yes, good. Naka, do you have some question or do you want to discuss more about this part? Well, this is the Yeah. We are hearing the question for EMG signal and control, and then we are talked about. Yes, this is a main interesting paper, and this is one interesting videos that we have watched to watch more practical usage of this. Yes, this kind of the knee supporting system. We don't know which kind of sensor is used. Sometimes EMG signal is used. Sometimes it's only the acceleration sensor or some other sensor is used to detect the situation or the user's intention. So therefore, I have shown this video. はい、なんか question or comments, something you have? Or we want to watch more or we want to discuss more about this section? この this part ね。じゃあ、ちょっと、we should move on to the another topic. フィールチェアトピックはいいか。なんだ。Your interest. で、EMG シグナルとか、EMG シグナル。 フィールチェアか。フィールチェア。リードサマーティック、フィールチェア。フィールチェアをグランドマス。うん、フィールチェアって、なんかクエスチョンってどういうか、フィールチェアクエスチョンなかったっけ？あ、コントロール、Q4 か。Q5。Question 5, wheelchair のコントロールとか something. So therefore, the next, we want to hear from you about your answer to this question 5. Yes? じゃあ、yes. ちょっと。誰が喋るの？
Okay. This is my answer of the question 5. This and explain the common input method of elderly and disabled to operate the electric wheelchair. The first is the joystick control. It is the most prevalent method, where users manipulate a joystick to control direction and speed. And firstly, the joystick translates physical movement into electric signals, and these signals are processed by a microcontroller, which interprets the input and sends commands to the wheelchair's motor controls. And thirdly, advanced systems may include adaptive logic. Algorithms that adjust sensitivity based on user strength and dexterity. And the secondary is the brain-computer interface. It can briefly said as BCI. BCIs enable users to control wheelchairs using brain signals. Brain signals benefits for those with several motor impairments, and it firstly utilized electroencephalography to capture brain activity, and then the signal processing involves filtering, feature extraction, and classification algorithms to interpret users' intentions. And secondly, the commands are then related on the wheelchair's control system. And secondly is the eye tracking control. Eye tracking system allows users to control wheelchairs by directly their gaze, offering a hand-free solution. Firstly, infrared cameras or sensors detect eye movements and gaze direction, and then the software algorithms map gaze points to specific commands, such as the map want to move forward or to left, and so on. And thirdly, some systems integrate with tablets or displays to provide a user interface. And I think Hugging use a wheelchair with the Apple eye tracking control. I think Hugging uses something like this. And finally is the electronomyography control, and it can briefly said as the EMG. EMG-based systems interpret muscle signals to control wheelchair movement. And it's beneficial for users who with residual muscle activity, and it firstly surface EMG sensors detect electrical activity from muscle contractions, and then the signals undergo amplification, filtering, and pattern recognition to determine intended movement. And finally, the commands are translated into wheelchair movement by the control system. And so on. 以上です。
Okay, thank you, thank you. Yeah, next student.
Mr. Roy Fan-san, could you please show your answer?
So first is the joystick and the electronic interface control. So this is the most common and widely adopted method. Users operate the wheelchair using a physical joystick or electronic buttons to indicate directions and speed. The applicable users of this are individuals with sufficient one hand and arm function. The advantage of this control mode is a high responsiveness and intuitive and easy to learn, but unsuitable for users with several motor impairment. And the second is gas control. They use eye tracking technology to detect the user's gas direction. The wheelchair move based on where the user looks. The advantage of this control mode is hands-free control and non-invasive, intuitive after training, but requires calibration sensitive to lighting conditions and user fatigue. And the example is Gas Driver by Mera. And the second is the brain-machine interface control. The brain signal typically use EEG are decoded and used to control the wheelchair. This allow user to operate the device by thought alone. The advantages of this control mode is no physical movement needed, highly accessible for severely disabled users, but still largely user trace requires long training period, costly, and prone to noise. The example is smart rolling, and the fourth is voice control. So users give verbal commands to control movement, such as go forward, stop. The applicable users of this are individuals who can speak clearly, but less reliable in noisy environment and not suitable for users with speech impairment. So, in my opinion, unless a user have severely limited mobility, wheelchair controlled by gas, brain machine interface, or voice may actually pose unnecessary risks for elderly individuals. For example, my grandmother cannot walk long distance, so she used to rely on a manual wheelchair, pushing herself daily to meet the friends and play mahjong. Seeing that it was slow and physically exhausting, I bought her an electric wheelchair with joystick and button controls. However, after trying it once, she was frightened. She felt she couldn't operate it properly and was frightened, afraid of crashing or falling. So as a result, she went back to using her manual wheelchair.
Okay, good. Thank you. Yeah, good point is your explanation with some examples, product example or some system example is attached is good way for your reporting. Hi, thank you. Yeah, next student.
Thank you. And next, Mr. Chen Yue-san, could you please show your answer?
Commonly good method for elderly and disabilities to operate an electric wheelchair. First is the joystick manipulator. The main motivation of the joystick manipulator design was to offer better universality, resilience, and accessibility to all users. In addition, the joystick manipulator is highly adaptable and open source, enabling a personalized control solution to be developed to better enable independence for the users. a key aspect of the design. Second is the facial movement. Enhanced free wheelchair technology allows people with limited mobility to use their facial muscles to control their wheelchairs. The control method uses electromyography sensors placed on a patient's temporary muscles to move a wheelchair or vehicle.
Okay, ちょっと I have a question to you. The facial movement, you say, but the which part of face and how to detect the face? You explain more in detail or contents?
Use the muscles on the face. Use the facial muscle to control the wheelchair. And use the electromyography.
Facial what? Muscle?
Yes.
Face muscle?
Yes.
Yes. It is also the kind of EMG muscle and electrode or something is the use?
Yes.
Okay, muscle ね。Okay, thank you.じゃあ、thank you. じゃあ、finally, the channel. Yes, please.
Here's my others see my screen.
ちょっと、so too small, but yes, please continue.
I'm sorry that this is a phone. Firstly, I would like to introduce that I didn't say anything about joystick because the question is the IND case and including the IND case. So I directly started from the BMI, and this is basically the most outline of the electrical wheelchair that's used for the paralyzed peoples that who have no abilities to control any of our muscles. And this part could use some EEG or even the impaired electrodes to collect the informations from our brains and operate the movements from the forward, backward, just so this kind of using has been impaired by Musk that in America that should be driven by Neuralink to operate some wheelchairs that for some bodies who have already been fairly confused by its situations. This part of works is actually just like using the BMI to communicate to control the prosthetics. It's just like the prosthetics hand or legs, but it's more easy because it's only need four vectors, four parameters: the forward, backward, the left, and the right. So it's more easier and the practice. And the second one is the nowadays using. It's called the vision-based gaze control with AI support. The most famous example of it is by the Stephen Hawking. Stephen Hawking just used this kind of systems that it just needs some glare to look at something, and it could drive the electric wheelchair that by analyze that where we looked, where we stared, and using just some regulated operations, and by the analyze of AI, the AI would like to know where we would like to go, and the AI will calculate
road to go to the place that we need to go, and the wheelchair will directly drive us there. It's just a kind of it is a kind of the automatic driving combined with the wheelchair. It is actually a very interesting use because it actually doesn't means that it makes the control it makes the parameter of the wheelchair downsize into one parameter. That's just the position we need to go. It is actually more interesting that for the development of the automatic driving growth, how we could redesign our systems that's called the electric wheelchair. The development of definitely different areas could actually make this new formation of nowadays research. This is why I use this for the second example.
Okay. These two you have mentioned in here?
What?
All you have mentioned?
Right.
Okay, okay. Hi, thank you. Yes, yes. Thank you for your answering. And what you have said is summarized like, これ、もうチェのをおしまいしてるよね。はい。なんか、ジョイスティック、ブレインシグナル、eye gaze, eye tracking gaze, EMG signal, and the joystick gaze, brain signal, voice control. Yes, voice control is a different one. Different one. Voice control, of course. It's okay. And the joystick, the facial movement, he said the muscle detection. And the channel is BMI and the gaze, vision-based gaze. And what you haven't say is maybe in this material also I have provided some examples like this is a gaze, eye movement control is also tested more than 10 years ago, and the other many researchers is try to do the gaze control, and also the BMI control, brainwave control is made by various kind of.
I recently mentioned gaze because the autonomous driving that make the gaze control differently new these days. It makes it means that we didn't use the gaze to input how we move. We just use the gaze to input the location that we need to move to. So this is the most interesting that nowadays gaze why have been a topic again.
Oh, yes. You have some opinion? Okay. Now, gaze control. When we say the gaze control, なんか tentative direction control, yes, the gaze direction shows the forward, right, and left. We can decide.
Right.
But of course, gaze or something is the meaning of the なんだっけ goal point.
Right.
Goal point to なんか pointing the goal is by base is also the one way.
So this is definitely way to the nowadays gaze control.
Okay.
So this is very interesting for the gaze control that the most traditional method be definitely new one.
Okay, good. And also this is brain go is a brain signal control. And the product presently produced by US company is what it's I will show some video. 待ってね。あと10分しかないからもうそろそろ考えますけど。はい。これか。スマートヘッドコントロール for ホイールチェアっていうビデオですけど。 と待ってね。
伊勢湾岸道新名神集中工事のお知らせです。6月
Hi, my name is Claudio. We at Monevo have developed a solution for people with reduced mobility to help them gain more freedom of movement and support in everyday life. Monevo Drive is the world's first wheelchair head control utilizing smart glasses. Intuitive head movements such as slight tilting and nodding of the head let you control your wheelchair safely and intuitively. The glasses adapt to your abilities within 20 seconds. Our control system can be recalibrated depending on your personal needs or preferred seat position. In addition to controlling wheelchairs, drivers can use smartphones and apps to take photos and much more. Monevo Drive is suitable for people whose mobility is limited due to illness and who therefore use an electric wheelchair. To use Monevo Drive, you must be able to nod and tilt your head within a range of about 1.5 inches in each direction only. Our technology allows people to continue to control their wheelchairs safely and intuitively, even with minimal head movements, for more freedom and mobility in everyday life. Monevo Drive has been approved as medical device since 2018 in Germany.
っていう話だそうです。This is one way is head movement control is also the one way, but this is also the slightly not stable in some case. So therefore, and also they say some calibration has been made and personalized something is also using some machine learning technology or something. But it is good or not, I don't know exactly. I don't know the user's feeling of it. Hi, this is なんか part of the wheelchair control part だったんだけど、you have some question or comments or you want to discuss more about it? ない、nothing. どうしようかな。あと10 minutes, less than 10 minutes. So, hand processes are not so much interesting. Orこれ、これだ。これか、eating support っていうのは、そう、ブレイン、これ、マインドコントロールプロセッシングアームとかって、このフィールチェアマウンテッドアームコントロール、例えば、eating support とか、eating support starting from the eating support, the wheelchair mounted arm is developed, and then this is about 10 years ago, the electrode is directly attached to the implanted inside the head. So the brain signal is directed directly by electrode. Brain signal is directly detected by something, and then the manipulator can be controlled by brain signal directly. This technology has been firstly started from about 10 years ago. なんか、implanted electrode detect the signal っていうの。various ways, not only the joystick, but the various way already try to do. これ、じゃあ EMG、これか。エデンプロジェクトって、ジャーマニープロジェクト。This is also about 10 years ago, but this is, you should watch this video. エデン。EMG コントロールだから、ちょっと we should watch this.
予防歯科、歯医者さんが大切にする考え方。予防歯科に大事なポイントがクリニカには全部入っています。さあ、歯の健康を守る予防歯科習慣を始めよう。クリニカアドバンテージ。
はい、そうです。
Mobility and independence allow us to be self-reliant and stay socially engaged. However, neuromuscular diseases, trauma, and strokes can reduce or even take this away at any time. Physical disability can restrict abilities we take for granted. Things like eating and drinking can become arduous and difficult. With the help of assistive robotics, people with disabilities can regain some of their independence once again. Our pioneering research from 2012 showed that it is possible to accomplish specific activities of daily living using a robot arm controlled with a brain-gate neural interface system. Control of such a robotic device can also be accomplished using measurements of muscular activity. These EMG signals can be recorded from the surface of the skin. Recently, we discovered that even people with severe muscular atrophy can use this kind of interface. Similar to a joystick, they can move the robotic arm up and down, left and right, and back and forth. As with the brain-gate interface, EMG-based commands allow a person to perform simple predefined tasks. While such an interface can be tricky to use and requires some level of concentration, it presents a first step towards an independent lifestyle for the user. Yet, manual control is cumbersome and unreliable. Artificial intelligence can help overcome these issues. Machine learning and cognitive reasoning methods are utilized to autonomously infer the user's intention and support task execution accordingly. To realize this goal, we built the mobile research platform Eden. Using Eden, we will continuously increase the capabilities of our AI-supported assistants. Our aim is to provide people with disabilities with an intelligent assistive device to perform usual daily activities such as opening doors or pouring water. Finally, our research will one day help people with physical disabilities to live more independent lives.
So, これはプロジェクトのプロモーションビデオなんで、this is the goal is that this like the realization of this kind of scene, using the EMG signal or the brain signal. This kind of project is many countries did and doing this kind of EMG control daily assistance system and so on. Yes. So the time has come to close today's class. So this is if you have some interest, you can access from here. This will be given. はい。じゃあ、なんか question? Comments? Okay. じゃあ、thank you for today. And next week maybe the rehabilitation training. Yes. じゃあ、that's all. Thank you. See you next time. Bye.